Get my pew here. Okay, awesome. Well, welcome everybody. Welcome to the GameOn Bootcamp. I hope you're in the right place. My name is Megan Unra, and I work for the Saskatoon Industry Education Council. And we are a nonprofit based out of Saskatoon. And our job is to provide career exploration events for students like you, so you guys can figure out what you want to do prior to leaving high school and not spend a whole bunch of money on a degree or something that you don't actually want to use. That's basically how I explain it. So we're typically based out of Saskatoon, but we were lucky enough to partner with Regina District Industry Education Council, so we could offer this to you guys who live more closely to Regina. And I'll let Kelly talk about that a little bit later. So I just want to go over a few things prior to handing it over to the main event. So here at GameOn, you can notice it's on Zoom, but we do have a chat function that Jason and Christina will go over here in a few minutes. And I ask that you guys make sure that you only put appropriate things into the chat. Please feel free to talk amongst each other. That's what it's there for. But just make sure you keep it clean, keep it polite, and just make sure you ask any questions and share any thoughts that you may have. But again, just keep it appropriate. We have Jason and Christina who are our instructors, and they are awesome. We were just trying to figure out before you guys logged on how many times we've been doing this, and we're going to age ourselves, but I think it's like, I don't know, 12 or 14. And they are very knowledgeable in this area. So you guys ask them any questions, but they have given up their Wednesday nights to hang out, or Thursday nights, I guess, to hang out with you guys. So please just treat them with respect. Again, they are very knowledgeable. So ask them everything you want to know. They have all the answers. And if they don't, they will find them. They know how to do that. But yeah, just be nice to them. Ask them any questions. And I think you guys will have a great time. It'll be a really good time. For this session, all the sessions will be recorded, and that way if you guys do miss a session, you will have to watch the recording to make up for what you miss. In the 3 hours you guys spend on boot camp, you do a lot of stuff. It is jam-packed, so in order to make sure the next week that you're good to go, you probably should watch the recording, so they'll make sure that that is accessible for you guys. Also for boot camp, we like to treat boot camp that we would treat a job. So if you guys are to go to work and you always show up late, what happens? You get fired. And we don't want to have to fire you guys. That really breaks our hearts. So all we ask is that you guys try and sign on to boot camp on time. Typically by 5:25, you want to be in that waiting room. And then Kelly will let you guys in by 5:30. And then by 5:31, you guys will be rolling and you'll be ready to go with all your coding and everything you're going to learn. And that way the 3 hours will be filled and you guys will be good. Okay, so just like a job, we ask that you guys be on time, and that we ask that put in the work for the 3 hours, and then you're done at 8:30. Okay, that is one of our main things we ask. If you're going to miss a session, Christina will give you the email later, but you will have to contact Kelly and let him know that you won't be here, because like today, we're waiting for people to sign on to the boot camp, and we need to know that you guys will not be attending. So we're not just waiting here and you don't get a text from Kelly being like, where the heck are you? So we just know that you're not going to be here. So it's really easy. Just shoot a text or an email to Kelly, not like 5 minutes before the class starts. Try and give him a little bit of notice. So probably a couple hours before class starts, and just let him know that you're not going to be there. Tell him why, and then just make sure you catch up on the recording after the fact. Okay, that sounds simple. Can you guys give me a thumbs up? Do you know how to give a thumbs up on Zoom? Your little reactions. Oh, thumbs up. Thanks, Matthew. Austin, Adam, awesome. Love it, love it, love to see it. Will, oh yeah, thumbs up across the board. This is gonna be the best class you guys have ever had. They're already right on it. Okay, awesome. With saying that, I will get off because you guys want to hear from me anymore. The rules are done. And with that, I will turn it over to Kelly, and he'll give you guys a little bit more information.
Oh, there we go. Hey, sorry folks, perfect example of how things get started up. You might have noticed that I was on my phone there. One of the students was just trying to get logged in and was having some trouble, and I'd been sending him messages and they were getting stuck in my outbox again. There's this problem with our email at Regina Public these days, so I'm kind of frustrated with that. Anyways, I'll say thanks to Megan for that great introduction, and I really appreciated how she kind of describes what our partnership looks like and what her organization does and what ours does. So I'm really excited to be able to bring this opportunity to students from the Regina area, which is where all of you folks are coming from. And we're just really happy to be able to piggyback on the very successful program that has been running out of the Saskatoon office for a number of years now. So I won't take too much more time than that, other than to just kind of reinforce all the positive things that Megan said about how we're excited to have you guys here and want you to treat it like a job and everything. I'm sure that we're going to have lots of fun along the way, but it'll be more fun for everyone if we do really treat it like a job and be really respectful and everything. So if anyone does have any problems, especially on the Zoom meeting side of things, check for an email from me, because it has all my contact info in it, including my personal cell phone number. So if anyone has something that's really an emergency, don't hesitate to text or even call if it's something that needs dealing with right away. So with that, I'll kind of sign off and turn my camera and mic off as well. I'm going to stick around in the background and look forward to hopefully learning along with you guys. So thanks, Christine and Jason. Take it away, folks.
Yeah, you bet. Thank you for the introduction. So welcome to Bootcamp, everyone. I'm going to start with just a little bit of a Zoom tutorial, only because you may be used to a different video conferencing tool besides Zoom. If you're new to Zoom, you should see a dock with a number of different tools that you can access, featuring all the different kind of features, I guess, of Zoom. Most importantly, the mute and unmute icon. So during this class, we hope that we'll be able to engage with you. We aren't intending to just lecture and have no feedback from you. We are hoping this will be like a conversation, a good learning opportunity. We'll get to know each other. So by all means, please feel free when you have questions or when you would like to contribute. If we ask a question, you would like to respond, you are definitely welcome to unmute yourself. We ask that you keep your mic off while we are presenting materials, so that we don't hear any background noises or get distractions.
Oh, this is working
over the mic. But you are definitely encouraged to join the conversation during these calls. And then as far as video goes, it would be great if you did have a webcam, so that at times you can turn your camera on so that we can get some reactions from you, because it's hard with these virtual classes to kind of get a sense of whether or not you're catching on to the concepts, because we can't, read your facial expressions. So at times it would be good if you did turn on your camera, but we're definitely not expecting you to have your camera on for like 3 hours straight for the next, 8 or so weeks in a row. That's going to be exhausting, especially when you're like hands to the keyboard trying to focus on coding and working on your games. It would be weird to all have our cameras on. We will be using chat quite a bit as well. So if your preference is to respond to questions in the chat or to ask questions in the chat, feel free to use that feature. I know sometimes it's a little easier than trying to like interrupt the sort of flow of speech to just pop your question in the chat. So definitely feel free to do that. And also, like, it's casual, so you can put comments in the chat as well. Try not to spam the chat too much, just because like Jason and I will be scanning it for questions and make sure that we don't miss anything. But definitely feel free to have casual conversation in the chat as well. And then the raise hand feature we're also going to be using. So if everybody could maybe take a moment to find where this is in Zoom and raise your hand, we'll get everybody's hands to be up before we confirm that we've all been able to find this in the UI. Looking like everybody's finding it, that's great. So typically we won't be using the raise hand feature to ask questions. We're more so going to be using it to track whether or not you completed a task. So we'll know we're ready to move on once everybody has their hands in the air. So again, if you do have questions, pop them into the chat or unmute yourself rather than using the raise hand feature. And also react if you want to. All right, so I'm going to talk a little bit about myself and then pass it to Jason to introduce himself so that you can get to know us a little bit before we dive into the material. So my name is Christina Shkovsky. I have a bachelor's degree from the University of Saskatchewan in computer science. I've been working as a software developer and now software development manager for almost 8 years now. I currently work at a company called Backlight. I work in the division called Backlight Creative. And this company is focused on media technology, which I absolutely love because I love movies. We don't ourselves make movies or games, but we build tools that help people to make their movies and their games. And I also spend quite a bit of time volunteering with an organization called Canada Learning Code. We focus on teaching like beginner-friendly workshops in coding. And specifically, we look at encouraging those who have historically been underrepresented in the tech industry to get into it, to try coding out. So that's me. I'll pass it to Jason.
Hi, I'm Jason. I have my PhD in computer science. My PhD research focused on games user research, looking at the psychology of players and how they relate to the main character in the game. And I'm currently working as the head instructor at a school in Saskatoon. It's called the Recording Arts Institute of Saskatoon. So it's a film school. We have kind of one-year diplomas in film, audio, like audio engineering, 3D modeling, and game design. So I run the game art and design one-year diploma program.
Awesome. So now you know a little bit about us, and we would like to know a little something about you as well. So we are going to have everybody introduce themselves. It won't be too intense, but we would like you to share your name, what grade you're in. That's going to help us understand some of the like foundational like math and science concepts that you may need to utilize in this course, whether or not you might have learned them yet in school. And then something that you like that starts with the same letter as your first name. So for instance, my name is Christina, and the thing I like that starts with a C as well is cats. I have a cat that is like smashing her tail on my keyboard right now, so hopefully she doesn't send any messages. And then once you share those things with us, then you will pick somebody from the list to go next, so we can kind of keep a nice flow going. You can look at the participants list, which is available in that Zoom doc at the bottom of your screen, in order to see a list of the people that are available to nominate to go next. And then once you've gone, you can raise your hand so that we know that you've already introduced yourself, and we can keep the the list of it organized. So I am going to randomly select somebody from the list to go first. Let's go with Trinity. Could you unmute yourself and share these few things with us?
Can you hear me?
Yeah, sounds good.
Okay. My name's Trinity Collert. I'm in grade 11, and I like trees. I nominate Will to go next.
Are you there, Will?
1 second. Is it working?
Sounds good, yeah.
Okay. I'm Will. I'm in grade 11. I like walruses.
Nice.
I don't know. I nominate Matthew.
I'm gonna tell you well. Hi, my name is Matthew. I am grade 10, and the only word my brain can think of is minestrone.
Nice.
Austin.
Can you hear me?
Yep.
All right. My name's Austin. I'm in grade 11, and I like apple pie.
Nice.
Stark, you can go next.
Hey, mic works, right?
Yep.
Okay. My name's Elijah Stark, and I like enjoyable art.
Nice. And do you like to go by Stark, or is that just like what your Zoom name happens to be today?
Yeah, that's just what my name happened to be.
Sweet. All right. Who would you like to nominate to go next?
Alexi.
All right, hello, my name's Alexi, and I'm in grade 11, and I like the ocean.
Awesome.
And I would like to nominate Adam.
Hi, my name is Adam. I'm in grade 11. I like apples.
Perfect. And just a reminder, if you've already gone, just raise your hand so that we can keep track of who still has to go.
Oh,
And who would you like to nominate to go next, Adam?
David.
My name is David. I like dogs. Hello.
Awesome. And who would you like to go next? Did you nominate someone?
Max Kim Sushkova. I don't know.
Hello.
Hi.
Oh, yes, it's good. Hello, my name is Maxim. I grade 11 and I like meat.
Awesome.
And next, I think Ernest.
Hi, my name's Ernest. I'm in grade 10 and I like electricity, or well, electronics.
Cool.
And I will nominate, let's see here. The person that starts with P, part, I don't know how to pronounce that. Oh, okay.
Hi, can you hear me?
Yeah, it's a little bit echoey, but try again.
Okay. So, hi, my name's Pertivi. I'm from grade 12, and I like pandas.
What was it? Could you repeat what you liked?
My name is Pertivi. I'm from grade 12, and I like pandas.
Perfect. Thank you. That sounded good that time. And who would you like to nominate to go next? There's a couple people that have gone, I think, that haven't raised their hands. So make sure you raise your hands.
Danielle?
Can you hear me?
Yes.
Yeah.
Okay. My name is Danielle. I'm in grade 12 and I like dolphins.
Awesome. And do we have anyone that hasn't gone yet? I think that's everyone, right? Yeah, there we go. See the hands go up. All right. So I will move on to the next slide. So just a note that, like Megan mentioned at the start, if you have questions about the course material, something about Unity, something about coding, something about one of the assignments that we were working on, you can definitely feel free to email either Jason or myself during the week. Typically, because we work during the day, we might not be able to get back to you like right away. But it's not like there's going to be like deadlines or anything for this class. You're not going to like have to submit assignments at the start of class or anything. So I guess know that we might not get back to you right away, but we are very happy to answer questions that you have, especially during class. I'm sure we'll be doing a lot of back and forth. That is specifically about like the course content though. If you have to contact someone to let them know that you're not going to be at class, Kelly's the best person to contact. So although myself and Jason, it would probably be a good thing if we know that you're not coming to class, we'll learn about that through Kelly. And it is Kelly that's recording all of the attendance. So it'd be great if you could let him know if you cannot be here for any reason. All of the materials that we're going to be using are in a Drive folder. So whether or not you have Google Drive account, you should be able to access this folder. We can paste it in the chat. And if you remember nothing else from today, it would be good if you remembered this link. So either bookmark it, take a picture of it with your phone, write it down on your arm, whatever you need to do. This is going to be like your lifeline for accessing all of the other information related to the course, including this slide deck that I'm showing right now. So as long as you have this link, you should be able to get everything else you need, your email addresses, your recordings in case you miss a class and have to watch it to catch up. Any of like your assignments, your notes, everything will be in this folder. During the sessions, we are very excited to be studying game mechanics. So we'll talk a little bit about sort of like the mechanics of types of games that you're maybe used to playing. We're going to be focused on, though, designing and implementing like a very simple 2D game. So in this 8 weeks, we are definitely not going to be developing something like a first-person shooter. We're going to start at the basics. We're going to do something very simple and in 2 dimensions. So think of like a top-down shooter or like a platformer, something that could get pretty intense and could be pretty fun, but has like more simple game mechanics, I guess I would say. I guess you could argue that depending on how intense your platformer is, but should be pretty simple mechanics. And we're going to be using the Unity game engine. So if you're not familiar with Unity, you will be by the end of tonight. If you have heard about it or have had a little bit of experience with it, I hope that you're excited about using it because it is a really powerful tool. And it is used in industry. So games that you actually play, and in some cases that you actually buy, are going to be created in Unity. So not all, but some for sure have been created using this tool that you're going to learn. As part of that, we're going to be writing code. So Unity has this like great interface where we can like add things to our games just by like clicking, dragging, dropping. But in some cases, we're also going to have to write code. And so whether or not you have any programming experience thus far, you'll all be learning hopefully some concepts that are new to you and getting some practice with some basic programming principles, principles that are going to be very relevant if you go on to use computer science in other classes or in life, because these principles are not just used in game development, they're used in all sorts of building of technology. As far as the format of the class goes, today especially, and as well as next Thursday, we're going to be talking to you quite a bit. So it'll be like slideshows and you'll have to like sit and listen. Though towards the end of both of those classes, you'll get to actually do like some hands-on stuff. But hopefully you'll be patient in actually like getting to touch your keyboards and just be able to like listen for a while, because we have a lot of content to get through before we can actually start doing things. And following that, we're going to be doing things like code along exercises where we will code something, kind of show you the behavior that it causes, and then we'll have you code afterwards. So basically we'll code first, you'll watch, and then you'll get to code after. And then there will be some individual work time, just where you'll have a chance to like implement concepts that we've learned, and then also just like work on your games and try to like customize them, because we'll all be learning the same concepts, but hopefully you'll be able to like apply them in different ways to create games that are a bit unique from each other. There will definitely be similarities though. This course, which we have been running for a number of years through the Saskatoon Industry Education Council, and now have the opportunity to run for students around Regina, is about career exploration. So yes, we're here to talk about games, to share our like love and passion for games, to learn how to build maybe your first game, or maybe you've done a little bit of game development before. But we are primarily here to explore a career option. So by the end of this 8 weeks, we hope that you will sort of develop an understanding of whether or not you think that computer science and coding would be something that you would want to do after you're done high school. Maybe something that you want to pursue in post-secondary, maybe take a course related to it, or apply for jobs in the industry. Hopefully this course, which you're not paying to attend, will help you kind of like decide whether or not it's something that you like and something that you would like to pursue, versus, going into maybe applying for a university degree, which can be expensive, and you might not even know if you're going to like it. So you'll hopefully kind of get a sense of that by the end of the course. And if you decide that it's totally not for you, worst case scenario is that you walk away with some relevant skills that are transferable to other areas that you may end up having a career in anyways. So let's talk about computer science a little bit, because although we're specifically going to be talking a lot about game development, it is like a subfield of a very large and diverse field of computer science, which is likely what you will be studying if you want to code games. There's a lot of jobs within games, right? It takes a lot of people with a lot of different skills to create games. We're focused on like the development and engineering of games. So we're talking about computer science, and computer scientists, they design and develop software. Does anybody know, and you can say in the chat if you have an idea, what is software? If you don't know how to describe what software is, you could give me an example of software if you would like to in the chat. Any ideas? So I'll maybe try to like get the juices flowing. So if I were to talk about software versus hardware, would you have an idea of what the difference is? That might help you kind of think of an example of a piece of software. Nice, I'm liking the answers, awesome. Series of instructions to complete a task, totally, yeah. Excel, totally an example of software. Yeah, awesome, like an application, exactly. Yeah, so when we talk about computers, usually we can classify like pieces of technology as either being hardware or software. So you could think of hardware as being the devices that you're using to access software. So for example, you may have a laptop. It could be a Windows machine. It could be a MacBook. That would be your hardware. And then potentially you also have a mobile device, maybe an iPhone, maybe you have an Android. That would be your the physical thing that you hold in your hand or that you use, the laptop that you open, that's your hardware. And then on that hardware, we install software, and that software are the things that we use to accomplish tasks. In some cases, that task is just having fun, like playing a game. But in other cases, they're applications that we use to accomplish different things, like keeping track of our schedules, or sending messages, or watching a movie. So I'm going to go to the next slide here, which shows sort of like a collage of different pieces of software as I imagine the concept of software. So everything from like computer graphics that we see in movies, to like animated movies, to smart home technologies and like voice technologies, like your Siri, your Amazon Echo, your messaging applications like Gmail for email, or something like social media. We have examples of applications like Chrome that you would use to access the internet. Something like software that allows you to operate a drone. Games are also on there, as well as something like a video conferencing tool like we're using right now. So software can be a lot of different things, probably stuff that you're interacting with like on a daily basis. And computer scientists are the ones that build those things. Oops, I went one too far. Okay, so last slide, I just want to mention, because again, this is a career exploration type of event, is that there are a lot of really good opportunities within computer science right now, and likely for the foreseeable future. So it is definitely a field in which there's high demand for people with technical skills. So you made a really good choice in signing up for this bootcamp. Hopefully it'll inspire you to continue to learn how to code, and then make you, or equip you with the skills that you may need to get a job in the industry, where there is a near 100% employment rate post-graduation. So if you equip yourself with these skills, it's very, very likely that you're going to find a job. And in most cases, that job is going to be a really good job that pays pretty good money, if that's something that's important to you, and something that's really flexible too. So if something like having time for doing hobbies and spending time with your family is something that's important to you on top of being able to have a full-time job, it's a great career to get into. It's very flexible in that you can apply for jobs, especially post-pandemic, essentially, not just in the place that you live, but you can work remotely quite easily if you have technical skills and are doing a job like working as a developer where it's sort of easy to work remotely without being in the same city as the people that you work with. And even if that doesn't sound like enticing to you, this isn't something that you see yourself doing as a career, and maybe it's just something that you're passionate about doing on the side, or you're just exploring. I think what you'll learn in this bootcamp will be relevant regardless. As we move into the future and we become increasingly reliant on technology, a lot of careers, not just careers where you're working as a programmer, are going to require technical skills. So we hope that you'll find some of the stuff that you learned in this course useful, regardless. And then another benefit, hopefully, of learning some of this stuff is that you're going to develop a deeper understanding of technology that you use. So next time when somebody asks you what software is, you'll be like, oh, I totally understand. It's something that you use every day, but maybe you don't have the ability to define it right now. But because it's something that's like so involved in our lives, it's good to have like an understanding of how it works. And then you can develop empathy for the people who create technology. So next time you get stuck in a wall while you're playing a game, you can show a little bit of empathy for the developers that work so hard to make that game. All right, so that's my spiel about computer science. And now we're going to get into the fun stuff, which is Unity.
Cool, thank you. So how many of you have heard the term game engine before? Does anybody know what a game engine is? Or does anybody know an example of a game engine that you've maybe heard in online or in pop culture or talking about video games? Unreal, Unity, yeah. Godot, yeah, Godot's the other third big one. Yeah, those things are all correct. So Blender is it's a 3D modeling tool, so it's definitely used in the game pipeline. But Blender is a program that specifically makes 3D models and does some texturing work and stuff, which are then imported into a game engine. But it's definitely part of the pipeline there. So I think you got all the main game engines. There's also things like the Game Maker. There's a Construct is another one that's used to be around. I don't know if it still is. In industry, the EA engine's called Frostbite. We have the Source engine. Some of those there's lots of different game engines. All the big studios kind of have their own, but the three big ones for our kind of developers, like indie developers or like hobbyist developers, is Unity, Unreal, and Godot. I think that's pretty much what everyone said. So Ernest is right. Game engines help simplify the process of game development. Any ideas or any suggestions about what you think those processes might be? What kind of things does a game engine do? Yeah, definitely. So we write some code, we type in some computer jargon, we give it to the game engine, and it uses that to build the game, to put it together and run the game. It does do some simplifying for coding for us, yeah. It for sure does the 3D processing. So we have this 3D environment. We place in 3D models, we place in text, we place in user interface elements, whatever. We build this 3D world and we hit play, and then we can just play the game. Okay, so it's sort of like a one-stop shop for putting your game together. Yeah, it stores the assets, it builds the game for, in our case with Unity and Unreal, multiple platforms. So you can press build and you can build it for Windows, for Mac, for Android, iOS, if you have the licenses, Xbox, PlayStation, etc. So it's really a single piece of software or a single program that allows you to put a game together and to develop a game and to build a game, okay? So generally a game engine has all of these things on this slide here. Any ideas what collision detection means? What's a collision? Not the resolution. Yeah, it's if you hit something. So if we have two objects in space that are flying towards each other, collision detection is essentially the game engine doing math. So when they collide with each other, they actually like bounce apart. Or you can't walk through the walls in the floor, right? So the floor is solid, the player is on the floor, you're walking along the floor, and you don't just fall through the floor. Or you run into a wall and you don't just run through the wall. Like Christina mentioned earlier, sometimes you get stuck in a wall, but that's a different problem. Yeah, so it's like rigid collisions, right? So it's like making objects solid and realistically doing the math for detecting when those things collide and also handling how they bounce apart, or if one thing's really, really massive, then it'll push the other one. All that kind of stuff is what's done by what we mean by collision detection. So that's one thing that's really useful, because the math for that, it's not super difficult, but it's kind of annoying to have to write that for every single game, all that code and writing all that math. So essentially with the game engine, you just put an object in and you just say, I want this thing to be solid, and then it makes it solid. So that if it runs into something else that's solid, they don't pass through each other. It just does that for you. Okay, so it makes it a lot faster to make a game. Related to that is a physics engine. So a physics engine is kind of the other side of the 3D simulation of the real world that we have. So a physics engine is dealing with things like gravity. So we can tell an object, we can say this object obeys gravity. So if it's in the air, it's going to fall until it hits something solid, which is the collision detection. Things like acceleration, velocity. We're going to talk about some of these terms at the end of today. This is all physics type stuff. So we can have, if two things are colliding, the way that they move when they collide with each other depends on the angles of the objects incoming, which one has more mass. All of this kind of math that deals with how objects are pushed around. That's what the physics engine does. Okay. Game engines also do the graphics for you. So we don't have to write our own code or our own rules about how objects are drawn. We just put a camera in the scene and we put objects in front of the camera. We move the camera around when the player moves and things like that. And basically the game engine just draws the world from the eyes of the camera. Okay, so we have a 3D environment or a 2D environment, and then we look through the camera and we just move the camera around. We see the environment, we see the game stuff happening, but we don't actually have to do the drawing of the camera. All that is handled inside the engine. We just see it through a little window, or when we build the game, it just appears in the window, okay? It handles sound and audio, so music, sound effects, all that kind of stuff. You swing your sword against the wall, it makes a clank sound. That's all stuff that the game engine allows you to really easily do with like 1 or 2 lines of code. You just say, play this sound, and it'll play that sound for you. We don't have to like write code to access the speakers or anything like that. It kind of processes all that difficult stuff for us. And it gives us this really nice kind of user interface where you can select stuff, we can drag stuff around, we can like drag something into the scene here. All this kind of stuff is handled by the game engine itself. Okay, so it makes it really easy to make games, as opposed to having just a blank screen with just a bunch of code that you just have to write gibberish for 6 hours and then press play and hope that it works, right? Does that make sense? Can anybody think of anything else that you think the game engine might do that's not on this list? I think the screenshot's an old version of Unreal, I think, maybe, or is it an old version of Unity? I don't actually remember. I think it's Unreal. Looks unreal-y. Yeah, okay, cool. Yeah, I think I covered most of the main things. There's definitely other stuff. It handles getting user input from the keyboard and mouse and controllers. It handles animations. It handles pretty much anything you can think about a game. The engine makes that aspect of game development easier. Saving and loading, networking, all of these like more complicated stuff is easier because we have this program that does it. So, like I mentioned earlier, a big studio like an EA or something like that generally will have their own in-house game engine because they tend to make the same types of games. So they have a game engine that's designed for those types of games, right? But there's also a lot of free to use game engines that are free for you to just download the program, try it out, look up video tutorials and kind of teach yourself how to develop games. It doesn't cost you anything except time. And you can kind of just like make your own game for free without having to pay for any software licensing or anything like that. Okay. Things like Unity, engines like Unity, which is what we're going to use in this class. There's also Unreal. Godot is another one, and kind of Game Maker Studio. I think that one, is that one free? I honestly don't remember anymore. And there's a few others that do it as well. No, it's not anymore. It used to be free, I think. So except for Game Maker Studio, like Unity, Unreal, and Godot, those are all programs you can just Google, download, and make a game if you know how to do it. For Unity and Unreal, there are licensing, like you do have to pay if your game sells really well, basically is how the models work. So for both of those, they're free to download and just play around with and build your own stuff. As soon as you have a game that starts doing well or that's making certain levels of profit, that's when you have to start paying royalties or doing a subscription model. And those models kind of evolve over time. So when you get to the point of publishing a game, you want to make sure that you know kind of at what point you have to pay and how to report your stuff and all the business side of making a game. But until then, if you're just learning how to do it, those two are completely free to use. Godot is open source, so Godot is completely free to use. You don't pay any royalties. You can do whatever you want with it. It's just it's community made, so it's not owned by anyone. It's just a program that people work on that you can use to make a game. It doesn't have this as like high features as Unity and Unreal generally, or the interface isn't necessarily as polished, but it's completely free, no royalties, anything like that. Okay, you don't have to be a professional to use any of these. You can always just learn one little thing a day, and you can sort of learn how to make a game gradually over time. All right, so we are going to use Unity in this class. We're not using Unreal for a few reasons. One is that Unreal is a really intense program. It's a little bit more complicated to use right off the bat. And it's also really, really resource intensive. So you wouldn't be able to use it on like a laptop or something. So Unity is pretty good for lower machines. We want to make it accessible to everybody. Okay. Yeah, I haven't used Godot very much. I've also never tried porting to consoles because you need to buy a development console, which is like thousands and thousands of dollars. Yeah. But if you're making a PC game or a mobile game, Godot is perfectly fine to do. Yeah, Godot's pretty great. I do like it. I have to use Unity at work and now Unreal, so I'm not going to learn a third game engine anytime soon. But I do like the idea of it and how it works. Okay, so we're using Unity. Unity is used in industry all over to make 2D and 3D games and experiences. It has support for VR, AR. It's cross-platform, so it's got mobile. All the consoles are on there. If you have a development console to build on, I even got it to work with my Steam Deck, which is like super easy to do. So you can basically port to any system. And like I said before, it's free for anybody that wants to use it. Once you make $100,000 in a single year from stuff you've made with Unity, so if you're a game company, you publish games. If you make $100,000 that year, you have to start subscribing for Unity Plus. And if you make more than 200,000, you have to get Unity Pro. And like I said, these things change every few years. So if you were to make a game, it might be a little different down the road. So always make sure to check that out. Does anybody recognize any of these games? We should probably update this list at some point. These were all the big games when we started this. I guess it would have been about 2017, right? Yeah, so what do these games all have in common, do you think? Yeah, they're all made with Unity. So we have Cuphead in the top left there. Pokemon Go is made with Unity. Super Mario Run, so the mobile game where you just tap to jump. Overcooked, I assume Overcooked 2 as well. Angry Birds 2 is also made in Unity, which is dating us even more, I think. Beat Saber, so there's a lot of VR games that are made with Unity. And Untitled Goose Game as well. And again, there's tons of others. You can Google a list and there's just pages and pages of games. Lots of smaller indie games are made with Unity. There's also indie games in Unreal, but that tends to be Ultra Kill as well, right? That sounds right. So yeah, lots of games have been made with Unity. So the tools we're going to use are the same tools that professional game developers that make lots of money making games, they use the exact same tools you have, okay? Or that we're going to be using here, which is really cool that you can use something that's industry standard. There's not a lot of other fields that you can use something that's like the top tool to use, right? And you can download it for free and use it. Oh, right. So this is again 2017. Should update this too. I'm just gonna play this this video here. This is from 2017. These are a few of the games that were made that year. This is like the best of games that have been made with Unity. And I think it's like a community. Oh, Night in the Woods as well. Okay. So this is kind of showing us what the engine is capable of once you know what you're doing and once you practice, once you like get together with other people who also know what they're doing and things like that. This is the kind of stuff you could do if you put the time and effort into it, basically. I think Tunic was also made with Unity, I believe. That came out last year. Unity and Unreal both are also really pushing 3D cinematics and things lately, and simulations and that kind of stuff. So they're really branching out beyond games. You can make full animated movies inside both engines. They have like full cinematic tools, cameras, all kinds of cool things to make animated movies and whatnot, which is also another reason to learn these engines, because in a few years, those two engines are going to be probably doing most of the 3D animation in the industry. So if you want to do a 3D animation or something like that, you're going to be using probably Unreal as well. Cool. So some of the good things about Unity, a lot of these are also true about Unreal, so I'll mention that too. Unity has an amazing online community. The Unity subreddit is actually really, for the most part, really good to follow, and it's really helpful. The people on there are generally really nice and helpful and patient and things. As long as if you're posting a question, as long as you've actually done your research and you're asking a legitimate question, there's tons of people that are really nice and are just willing to help you out if you get stuck or if you have trouble and things like that. There's lots of learning resources online for Unity because it's Unity and Unreal are kind of the top two engines. So there's tons of YouTube videos from all kinds of different people and sources that are saying, here's how you do this one little thing in Unity or Unreal. So there's lots of tutorials you can find. There's lots of resources to learn these things. If you have a question, you can Google it and you can probably find 10 different ways of solving that problem. Learning Unity sort of forces you to write code, although they did introduce a visual scripting thing that actually works last year. So that's not exactly true anymore, but you still have to learn to write code and to think in the way of a coder and to organize your game mechanics and instructions. So it teaches you a new way of thinking that you can use in other areas of your life and other fields, other jobs, things like that. It does all the hard math and physics for you. So like we said before, you don't have to calculate gravity necessarily. You just say, give it gravity and it has gravity. Or make this thing solid. You don't have to write the math of detecting two objects intersecting with each other. You don't have to do that geometry. That does it for you. You still need to know kind of what's going on, but you don't have to actually do the math. You just have to kind of understand what the math is to the point of realizing if it's going to work or not. And it allows us to get a game working really quickly because it does all the hard stuff for us. We can focus on the higher level game design, and we can our code can write these like game mechanics, but we don't have to worry about physics, math, drawing. All that stuff kind of comes built in. So we can get something up and running. I'm going to say quickly, although as we'll see in this course, it's not exactly that simple. But once you know what you're doing, you can get something up and running. Within a week, you can have a prototype of a game, as opposed to what it used to be, which would have been like months and months. Okay, so any questions about what game engines are? Or any questions about Unity or Unreal? Or Godot, I guess. I can't really answer those, but someone in the chat might be able to. No? Okay, cool. The next thing we're going to do is we're going to open Unity and create a new project, and we're going to go through just some of the basics of the interface and some terminology and things like that. So what we're going to do is I'm going to walk you through how to create a new project in Unity. And then as you guys are opening up your projects and waiting for that to start, we'll take a short break probably. And then we will go through some of the basics, okay? So I'm assuming everybody has installed Unity. If you haven't, you will not have it installed by the end of class today because it takes quite a while, probably. So does everybody have a program called Unity Hub? Let me rephrase that. Does anybody not have a program called Unity Hub? If you have it, open it up. And to launch it, start it, sign in with your Unity account. And if you don't have, I think the instructions probably said to create one, but if you don't have a Unity account, create one and log in with it. And we're going to create a 2D project. So in Unity Hub, the program looks like this. We're just going to click the great big blue new project button. I'll do this again after as well, but we want to pick a 2D game, so 2D core. You may have to download the template. I don't remember what it's like when you first download it. You want to give it a name. So name it something that is meaningful, not my project. And choose a location to save it. This part is super important. You need to choose a folder where the project's going to be. because later you're going to have to find that folder at some point. Okay, so I'll leave this up here for a while. Once you have Unity, once you've clicked create project and it's starting to be created, I want you to raise your hand so we can kind of keep track of who's done and who still needs help to do it. Okay, so again, we want to, how do I go back? You want to click the big create new project. We want to do a 2D core game. Give it a useful name like, I don't know, Bootcamp or something, or GameOn, and choose a file location to save it. Somewhere that you have, somewhere probably on your C drive, like C in documents is a good place where you have like write access, so you don't have permission issues, which sometimes happens. And then once you click create and it comes up and it's like going through the loading bar, raise your hand. And then once everyone's got that set up, I think we'll take a break, right, Christina?
Yeah, that sounds good to me. And then if anybody's machine is taking a little bit of time to create the project, then no worries.
Yeah, sometimes it does take 15-20 minutes depending on your machine. So you won't need it for a while anyway, but we want to make sure everyone's good to go. What's this? If you have any questions, feel free to ask in the chat. We'll be happy to help you. So we're going to just do a little top-down game. So the focus of this particular bootcamp is specifically geared towards coding. So we're like approaching game development from the coding mechanic side. So we're not going to have like super flashy games at the end. We're going to have games that have basic mechanics. We're going to teach you how to code mechanics. So we're going to have some stuff that we're going to have a player that can move around the screen with WASD. And if you touch an object, if you collide with an object, you're going to die and have to respawn. If you touch another object, you can go to another level. And we'll have some coins to pick up in some of those kind of basic mechanics. And it's going to be kind of a top-down perspective. That's the main style we're going to be working towards. And we're going to write basically all the code for that for all those mechanics going to be written by more or less from scratch. But again, the focus is on the coding more than the design. So there's going to be a little bit of art and a little bit of design, but we're focusing on the computer science coding part of it. Does anybody need any help getting to this point? Do you need me to go through the Unity Hub part again? Or is everyone good?
Looks like most hands are up, so that's great.
Yeah. It will take a while. That's why we're doing this now, not when you need it in an hour. Okay. And just for context, when it's creating a project for you, it's generating literally thousands and thousands. I think it's about 7,000 or 8,000 files it's creating, and it's creating a project structure, and it's setting up shaders, and it's doing so much stuff in the background that it's like setting up this project for you that does so many different types of technology. It's all being like connected for us right now. So that's why it takes so long. It's because it's having to copy literally 8,000 files and put them in the right file structure and whatnot. Once you have a project opened the first time, the future, until your game gets really big, it doesn't take as long to open it up again. Once your game gets big, then you have the same problem of having to open up all these files. But for what we're doing here, it should take less time next week and the week after, etc.
Should we step away for a break?
Yeah, I'll take like a 10-minute break, especially if it's going to take everyone a while to.
Sounds good. Okay, so let's take 10 minutes. Make sure you like get up, stretch your legs, look away from your screen for a few seconds at least. And we will meet back here at 6:47 to start diving into the Unity interface. So put that in the chat just in case you forget. Meet back at 6:47.
Jason or Christina, are either of you guys within earshot? Trinity, you're still there, right? You can turn your mic on, I think. I don't know if anybody else is even around listening. Oh, there you are. Sorry, I didn't notice you'd answered. Okay, so can can you start Unity? You have the program started? Okay, so then what you need to do is tell it that you want to start a new project and you want to choose a 2D project. Now, this is where I hope I don't steer you wrong, because if I even go backwards, I'm not sure. I've never played with this before either. I'm totally learning. But you basically just need to make sure that you know where it's going, know where you're saving the project to, I mean, and give it a name that you're obviously going to recognize, but that you're starting a 2D project. And that's really all you need to do. And once you get your computer working on it, it'll take a few minutes at least, and that is why we're taking a break right now.
Okay, so I hit the create project, and then it took me to learning templates. So I downloaded this 2D platformer micro game. So
yeah, I think I was going to do the same thing, and I stopped myself from doing that. I think it was a good thing I did. So how did I get that? So when you went to new project, you should have had a bunch of options, and the very top under all templates, the top option should have been 2D core.
okay,
I think you can even start a brand new one right now. That's exactly what I'm doing.
So I hit the create game, and I might have hit it with the 2D platform micro game, and then right now it's just loading.
Oh, I think Christina just jumped back on here. Christina, I'm talking to Trinity and very poorly trying to stumble through getting her back to where we all are. I'm glad someone with more experience and with screen sharing. I'm running Unity on my work laptop, not on my not on the one that I've got the meeting running on, so I can't even share my screen to show her what I'm doing. I'm going to shut up now and let Christina help.
Okay.
All right, did everybody find the stuff, the options? Or is anybody still, did anyone need me to show the Unity Hub part again?
Jason, it might be worth going through things again, just because I know that Trinity, for one, lost her connection for a bit there, and I think Christina's helping her out, but it never hurts to see things again, especially for the first time for a lot of people here.
Sure, sounds good. Okay, so this is a program called Unity Hub. We're not going to do like a ton with it for the most part. This is just your launcher for creating a new project and for opening your existing projects. So if this is your first time in here, if you're creating your project, when you get to the actual program, on the left, it should be in the projects tab. That's the default, so I'm guessing it's probably there. We want to press new project. The type of project we're making is 2D core. So this is important because this is going to set up our project to make a 2D game right out of the box. If you did 3D by accident, then you're going to have to import a lot of things inside Unity to get to 2D. Okay, and the same with like vice versa. If you're making a 3D game, you should start with a 3D project. It's just the basic default configurations. Okay, so the core games, these cores are just sort of the bare bones engine that we're going to build a game on top of. There are some other templates down here, like the 2D platformer and some of these other ones. These are like learning templates. So the point of them is they show you, it starts with a game that's kind of pre-made for you that you can kind of look at and figure out how to make a game by looking at a game that already exists. It allows you to play around with some values on them and things like that, which is a really good learning tool. I encourage you to look at some of these on your own. There are accompanying tutorials on the Unity website that go with these micro games. These are not the ones we're going to use here, though. We're going to be just using a 2D core game because it's going to start, which is a bare bones project that we can build a game on top of. Okay, so we want to pick a 2D core. You want to give it an interesting, unique name that you'll recognize later. And you need to pick a place to save it. So I think it'll default, it probably defaults to the C drive. I'm guessing like your documents or something like that. That's fine. If you want to create your own folder, that's also fine. Just make sure it's a place that you're able to save files to. We have had issues in the past where people maybe saved it in like their downloads folder or something, and that caused like read-write issues down the road. So save it in the same place you would save your like Word documents or whatever your school document stuff, okay? And it should be good. Once you have all that set, give it a name, save location, you hit create project, and then it's going to go into the loading screen and take about 10-15 minutes to start the project. Next week, when you go to start up your project and you go to the Unity Hub, you should see the project you created today is in this list of projects. So these are all the projects you've opened recently. So next week, you can just go to the hub and click on this, and that'll open the project that you have recently. So this new project is only the first time. Okay, after that, you'll just reopen it through this little shortcut here. Okay, does that make sense to everybody? Cool. So because I don't need it, I'm going to close. I'm just going to minimize it for now. All right. So if your hand is up, you can put your hand down now. Thank you. I know I have the option to lower all hands. I can never find where it is. So the next little bit here, I'm gonna go through just the basics of how the Unity interface works. We're gonna go through the actual software a little bit in the engine. For this part, you do not need to follow along. In fact, I encourage you not to follow along, because if you're jumping back and forth between windows, you're gonna miss important stuff. So I'm gonna show you the basic interface, where things are and where to go to do different things. And then we'll talk about some terminology, and then we'll get into some actual practical stuff kind of at the end. Okay. But for this part, just sit back and watch and listen, and I'll explain sort of how the engine roughly works and where to go to do what. Okay. So this should be what the interface kind of looks like when you open a new project by default, usually, I think. So my project looks like this. This is what Unity looks like. Now, you notice there's all of these different windows with little tabs here. Each of these is a different window, or I think they're called panels in Unity. So it's a different panel that does something different. So each of these is a different piece of the engine. Does a different task. They do different things. If you don't like a panel where it is, if it's something you never use, once you know what you're doing and it's something you never use, you can just right click and you can close that tab if you want, if you don't want it open right now. If you don't like the way things are laid out, I can take, like, this console, for example, I can click the tab part, I can drag it, and I can just move it wherever I want. So I can rearrange the interface, whatever suits what I'm doing right now. So you can have different layouts for different workflows. Sometimes you want to have different windows and different orientations. So you can customize the way things are laid out for what you're doing, or whatever you need. Or if you don't like the way it is, you can change that, okay? For now, I recommend you stick with the default layout for the first day or two, just so when I go to a window, you also go to the same, you know where to look for that window, and you know where to go to the same place. So if I say, like, go to the hierarchy and you have yours rearranged, you might get confused about why mine's on the left and yours is on the right or something, okay? But eventually, once you kind of know where to go and what to do, you can rearrange it how you want. Okay, so I'm going to talk about these 5 windows just a little bit and sort of go through roughly what you do in each of these. These are the 5 main ones. Yeah, these are the 5 main ones that we're going to work through with our when we're making games in Unity. So let's start with the hierarchy panel. Okay, so the hierarchy is on the left here. Okay, this is going to be your list of everything is currently in the current level that we're working in. So at any given time, we are working inside of a scene, which is basically a level. It's like a collection of art, sound, scripts. It's a collection of game objects, which are assembled together to make a single level or something like that. And this is a list of everything that's currently in the game or the level. Just to check who's actually paying attention. Which game object do I currently have in my scene right now? I have one game object. What is it? Yeah, it's a camera. So it's called main camera. What do you think this object does? Does camera things, right? It's kind of like if you have a camera and you're looking through it, right? So this object is the camera. I can, in the hierarchy, if I have more than one object, I can select an object to select it, and then I can edit it. I can do what I want with it. But this is where we can go to see all of our objects. We can rename them. We can reorganize them. We can do all kinds of restructuring in here. And this is an easy way you can kind of, eventually you have a lot of game objects. You can kind of scroll through this list and find the thing that you want. And this camera, if you notice in this window here, there's this white outline. Everything inside that white outline is what's going to be shown if I was to play the game right now. Okay, that's what a main camera does. But in general, this is going to be just the named list of everything that's in the game. And I can select the different things in this list to select them in the game. Okay, sometimes it's easy to find it by name, so you can just scroll through and find it by name. Okay. That's what the hierarchy panel is. If I right click in here, there are a bunch of sort of default things that we can create, like a camera, but I already have a camera, so there's no point in having a second one right now. If I wanted, I could add a light. These lights only work for 3D games, so we're not going to be using lights in this class, but if you're doing a 3D game, this is where you'd go to create a 3D light to start lighting up your scene, your levels. We can create effects, we can create 2D objects, we can create 3D primitives. This is kind of where you go to create your just basic kind of structured objects. Okay, so again, hierarchy, we can right click and we can even create an empty object if we want. Okay, that's a hierarchy. It's like a list. It's a listed visual representation of what's actually in the scene by name, and we can select it to select the thing that's actually in the game. If you have questions as we go, just throw them in the chat and I'll answer them. The next window is the project panel. Where is the project panel on your screen? Someone show me where tell me where the project panel is. Bottom left. So down here, yeah, it's split with the console. Actually, the console is not on that list, so I'm just going to mention it now. Was it next week? We're going to start writing code, or the week after. Whenever we start writing code, you're inevitably going to have errors where your code is not formatted properly or something happens when you're playing the game. This is where there's going to be a bunch of red text that tells you what you did wrong when things go wrong. And for debugging, yeah, exactly, stuff like that. So the console is going to be super important when we're coding, because this is where we go if the game's not working right. This is the first place we're going to tell you to go to look for an error message. So if you press play and it says cannot play, or if you press play and the game's not working right, the first thing we're going to tell you is to go here to the console and look at what's there. And if there's any big bright red text, then we're going to ask you what it says so we can fix the problem. Okay, it's going to have red text that tells you what the problem is. Yeah, that's fine if it's still being created. Just watch on my screen. You're not supposed to follow along it anyway. I just want I might ask you to like go to your project just to like refer to something. But for the most part, try and stick with the screen here so that we can all stay together, okay? All right, that's the console. Project panel. Any ideas what the project panel is for? So right now, my project panel, yeah, this is all of our assets. So organizer, yeah. So this is where we collect all the stuff that we're going to put in our game. So if we want to have an image in our game, this is where we would put the image, or this is where we would import the image to. If you've ever used a movie editing program, it's a similar interface to that. Whereas like the hierarchy can kind of like your timeline where you drag your video clips and organize them. And then this project panel, this is just all of the raw assets, the music, the sounds, the images, the 3D models, shaders, materials, all the actual like individual pieces are all saved down here. And then we can just add them into our game as we need. So if you're importing art and things like that, this is where you would import it to. And then we would use that in the actual game itself. Okay, that's what the project panel is for. To import something, we can, again, just like with the hierarchy, we can right click here. In the project panel, we can right click and we can just say import new asset and basically go through your file system and find the image that you downloaded from the internet or that you made, and then you can import that to your project. Yes, we will be using spreadsheets in a few weeks. Okay, so again, we'll review all this as we use it, but again, in a project panel, we just want to right click and then we create new or import new asset, and then we just find the thing that you created or downloaded. Okay. All right, next is the scene view. Where is the scene view window? Yeah, it may be a little different depending on how it is, but it's kind of this middle section here. This big middle section, right? I'm actually going to do the scene view and the game view together here because they're like side by side right here. Okay. So we have the scene view and the game view. The scene view is where we build our level. So this is where we actually rearrange stuff, where we move things around, where we can place down our images and all that good stuff. What do you think the game window's for? Any ideas? Yeah, that's when we play our game. So you see there's a great big play button at the top here. If I'm in the scene view, if I press play, it's going to shift over to the game view. And then it's going to literally play the game. So based on all the objects that I placed in the level here, based on all of the code we've written, anything we've done in our game, it's going to simulate the game from this point in the game window. So this game window is looking through this camera we talked about before. Okay. So we can play it. We can check the same button again to unplay it as well. Okay. Back to the scene view. I'm just going to create an empty 2D sprite here just to show you the different tools. Again, we'll go through all this when we actually start doing stuff together. I'm just going to show you the rough basics of it. Scroll wheel to zoom in and out, right click to pan. I can also click on this little hand up here in the scene view, and this is the pan tool. The little arrows or the move tool. And so I can grab one of these axes and I can just move the object around. Notice if I move it around, it also moves on the game view here. So the game view is always looking through that camera, whereas the scene view is just kind of this more open sandbox where I can place something over here outside of the camera. It's not going to show up, but it's still in the game. So we can build a level outside of the camera. And then if the player happens to move over there and the camera follows the player, eventually we can get over to this location. And this the stuff we built over here if the player just walks over there. Okay. Rotate. We can rotate the object. Control Z to undo. I can scale it to resize it. And then this little rect tool here allows me to kind of freeform stretch the 2D sprite. Okay, that's our basic tools in the scene view, and I think that's pretty much all we're going to need for this class. Is kind of these move tools in the scene view. In the game view, we're not going to do much here actually really at all. We'll go through a few things later, but for the most part, this is where we go to just watch our game when we play it. Okay, and when we press play, we automatically go here. One thing to be careful of is if you're in the scene view when it's playing, we can't control the game from this. So if we're in the scene view and you're trying to like WASD around, you're not going to actually be WASDing. You're going to just be like toggling some of these tools because some of them are hotkeyed to the W key and stuff. So you need to be in the game view, and sometimes you have to click in there to actually control the game. Okay. And the last thing is the inspector. Where's the inspector panel? Yeah, it's on the right side. Okay, so the inspector panel over here, you may have been watching the inspector panel as I was doing some of these things. What does it look like the inspector panel does? If I like click on stuff, what's happening? I click on the camera, and then if I click on the square here and then back, what's happening? Yeah, it's the properties, right? So I select the camera, and then here I have a whole bunch of different numbers and settings I can configure that controls how the camera behaves. right? So if I click on this little blue spot here, I can open a color picker and I can change this to bright magenta if I want. And notice if I go to the game view now, jeepers, the background of the camera is now like hot pink. Just gonna not do that though. And that's true for all of these properties. Okay, so like this is just showing us all the settings for the thing we have selected. Okay. So if I click on the square, it shows me sprite settings or image settings for this thing. So again, I can maybe not pick magenta this time. I could make this like more of a cyan blue color or an orange color. Right. So this is where we can go to kind of configure some of the things about a game object. My computer is getting very laggy all of a sudden. That's the inspector panel. So that's where you're going to go probably the most often. Besides placing things around the level, you're going to go to the inspector a lot to do settings and things like that. I think that's pretty much all we need for the interface right now. Are there any questions about any of those panels? So the basic workflow is we import stuff down the project panel. We can also create things like I can create like a 2D sprite here, and there's some primitives to create. And then once I have the square created, I can just drag it into the hierarchy to add it, or I can drag it into the scene view. So we create things or create or import things in the project panel. We add them to the game. We move them around in the scene view. We can use the hierarchy as like a more of a quick select tool. Notice if I select it here, it also selects it here and vice versa. So it's kind of a one-to-one relationship there. And then we press play to play the game view the way it's been laid out. Okay, we do settings over here that we can then add game mechanics, and then we have a game. Done. It's obviously more complicated than that, but that's the basic workflow. All right. I'm going to talk about some terminology now with Unity. I noticed a few of you have already been using it, like things like game object, so that's good. But we're just going to go over some basic terms to make sure everyone's kind of on the same page. When I say something, or when we say something, you have heard it before, so you kind of know what's up. Let's start with assets. What's an asset? We kind of talked about this already, but yeah, parts of the project. So things like code, which we're going to call scripts, images or sprites, textures, 3D models, sound effects, music, particle effects, text files, shaders, all kinds of stuff. Anything that's just like a base component or like a piece of art or a piece of code or like a piece of something, one little thing that's a building block in our game, that's going to be a asset. What is a sprite? That's the stuff there. What do we mean by sprite? Characters in the game? Yeah, characters. Yeah, they're basically images. So we're making a 2D game in this class. So our basic pieces of art in this game that we're making will be sprites. They'll be 2D images. So a sprite is a 2D image that's used as like a 2D object in a game. Okay. So like in the Unity example over here, these little boxes are sprites. They're kind of boring sprites, but they're still sprites. So they're like a 2D image that's used as like a 2D object in our game. Anyone know what a sprite sheet is? There's one or two of you who were asking questions about sprite sheets earlier. Yeah, a bunch of images. So you notice, you see this, like all of these images of a bunny rabbit here. What are these images doing essentially? Why are they here? Yeah. So imagine if you've ever, I don't know if you would have made like a flip book as a kid, where you draw the same image but a little bit different on every page, and you kind of flip through it. Each of these little separate images here is the bunny rabbit in a slightly different pose. If we were to play these very quickly in succession and loop it, it would look kind of like the rabbit is hopping, right? So they're framed, you're right, they're frames of an animation. So each of these is an individual frame or an individual piece. And if we play them all really fast, it looks like the bunny is animating or hopping around, right? So generally you would import these as a single image, and you would tell the engine that these are actually separate images, separate sprites within this one image file. And then you would set up an animation to kind of play through these, to cycle through them very, very quickly so that it looks like they're animating. And that's one way we could do 2D animation in a 2D game. It's like one of the main ways is in this, doing this. All right. Another concept is a game object. So a game object in Unity is a single entity that's in our game. It's a single thing. So it's the player is a game object. The camera is a game object. The enemies are all going to be game objects. If there's coins in your game, those are game objects. If there's like a potion or a heart that you walk over to heal, those are game objects. If there's spikes that damage you, every sort of single entity in your game is going to be a game object. So in this case, in Unity here, the main camera is a game object, and then these 3 squares I created, these are all separate game objects. Okay, so basically every individual entry in the hierarchy or every individual thing I can click on here is a game object. A game object it represents a single thing in your game. So the player, the camera, the enemy, the spikes, the coin, but it really acts as a container for these things called components. It will always have a transform component, but we can add a whole bunch of components onto a game object, and that's what makes that game object have unique behavior. So if we look at this square here, the square game object, it has a transform component. This transform component is what gives this object a position in the world. So it has a position, a rotation, and a scale. Talk about that in a minute. But it also has this thing called a sprite renderer. And what the sprite renderer does is it makes this game object display a 2D image. If I turn it off with this checkbox, or if I were to remove it, this would no longer have a 2D image. Okay, so a game object is a container for a bunch of these components. And as we add components, we sort of build functionality onto this object. So we add a sprite renderer, it renders a sprite. It draws a picture, a 2D picture in the game. If I add we'll see different components at the end of today that'll make it an object behave with physics. It'll give it gravity. It'll make it solid so that it collides with things, right? All of these kind of things we can achieve by just adding components. In a week or two, when we start writing our own scripts together, each script that we create or each piece of code that we write is going to be a custom component here, which we can also add to add functionality to things. Okay, so in order to make this game object do something interesting, we have to add a component with instructions on how to be interesting for whatever we want it to be. Okay, that's probably what I said. Yeah. So does that relationship make sense? Every entity in our game is a game object. A game object is made up of a bunch of components. Each component gives it a unique behavior. We're good? The next term is a script, which I've used a few times so far tonight. A script is basically just a set of instructions. So this is the code that we're writing. This is the computer code. Next week, we're going to be doing a lot of coding structure and things like that. So we'll be learning more about how to make scripts next week. But if you've ever done anything, any computer science classes, or if you've ever written any code or like something like HTML or JavaScript or like C# or something like that, or Python, that's what we're talking about with scripts, is step-by-step instructions or computer code that essentially we're creating a custom component. We're creating a component that makes an object behave in a certain way to do a certain thing. Okay, so once we create a script, we can add it as a component onto an object, just like sprite renderers and physics things and whatnot. And on a game object, there's a great big add component button over here, which is where you can go to add tons and tons of different components. I think the last thing here for me, this is something that we're going to be talking about a lot with our coding and with the math and things, so this is important to cover. Like I said before, every game object has to have a transform component. So it has a component on it which tells the game engine where it is and with what orientation and size it is. Okay, so every game object, even if it doesn't have anything else, it has to have a transform, because the game engine needs to know where it is. It has to have a physical location in space. So position is the term that says, where is this object in space? And because we're doing a 2D game, this is one of the reasons why, our little happy face sprite here has a position which consists of X and Y coordinates, where X is its position horizontally here relative to some arbitrary 0, 0 value. And the Y coordinate is the height. So it's essentially, you've probably done this in math class before in like geometry or something, I hope. But this smiley face has a position that is defined as like how far it is horizontally in the X and how far it is in the Y. So if I change the X position of this, it's changing it left to right, where right is higher and left is smaller. And Y is vertical up and down. Okay, so X and Y. We're not dealing with Z, which is depth, because we're doing a 2D game here. Rotation is how it spins around. We won't do a lot with rotation, so we won't talk much about that, but we can rotate an object too in 2D or 3D. And then scale is how much it is stretched. Okay, so these three things together tells the game engine where an object is and how it's oriented and how it looks. Okay, I hope that's somewhat familiar, because we're gonna be using it a little bit when we start coding next week or week after, I guess, maybe. To make the player move, we're gonna have to use this to tell the player what coordinate to move to. Okay, so that's all from my part here. Are there any questions about some of those terms? Before we get into some physics? Yay, physics. I think we're good.
Awesome. So now that we have somewhat of an understanding of what a component is, we can start talking about other components that we're going to be using, not just the transform, although that is going to be one that comes up a lot. We are specifically now going to talk about two of the physics 2D components that we're going to be using quite a bit. Starting tonight, we're going to have you add these components to game objects to see how they behave once those components have been attached. The first one we're going to talk about of the physics 2D components that are important for our purposes is the rigid body 2D component. So this one is pretty cool because it is going to place a game object under the control of the physics engine. So this engine that makes Unity such a powerful tool that handles all of the physics calculations for us, we're going to be able to utilize it by basically telling the game object that we want it to be impacted by the forces of physics in the game. First, what we're going to see when we add this component is that an object that is like flying suspended in the air, when we attach this object, or sorry, this component to it, is all of a sudden going to be impacted by the force of gravity. So what's going to happen to it? Any ideas what we're going to see happen to that object in the game when it is impacted by gravity? Yeah, it's going to fall. Exactly. So that'll be the first sort of like confirmation that we get that attaching this component to our game object has worked, and that physics is happening. There are some settings on this component. So similar to what we saw with the transform, where the transform was controlling things like the position and the rotation, there were different settings that you could see in the inspector and then modify. The rigid body 2D component has 4 different settings that we're going to be playing with this evening. In particular, we're going to have you play with the gravity scale, linear drag, and angular drag. All 3 of those, we're going to have you play with those when we do an assignment right away here. So first of all, of the significant settings that we wanted to point out is the mass. So how much force is actually required to move that object? I guess technically this could also in real life impact like how fast something is falling due to the force of gravity, right? Linear drag is going to, you can think of it as like air resistance. So this is a force that essentially slows the movement of some object once it's put into motion. So if we have some object that is like flying through the sky, air resistance is going to slow down the movement. We call that linear drag. So we can modify that so that the object is slowed down or not when it comes to the position when it's moving. And then an object that is rotating, which is also movement, we can measure how quickly it'll stop rotating based on setting the angular drag. So as we increase and decrease these values, we'll see something different happen when it comes to starting an object in motion and then seeing it come to a stop, whether that be like the actual position changing or the rotation. And then the gravity scale. So sometimes in our games, we will want objects to be put under the control of the physics engine, but not to be impacted by gravity. So think about like a platformer, for instance. You do want your player to be impacted by gravity, right? So as they're like jumping from platform to platform, if they are to jump onto the platform, they will be able to stay in position. And if they are to not jump onto a platform, then they're going to fall, right? And probably restart the level. And so in that scenario, the platforms, we don't want them to be impacted by gravity. We may want them to be impacted by forces of the game, such as a player jumping on one end, and it's sort of like a platform that moves in response to the player jumping on it. But maybe we don't want them to be impacted by the physics at all. And so we can set the gravity scale and still have forces impact different game objects without actually having them fall out of the game view. The Collider 2D is another component that we'll be experimenting with tonight. This is going to be for handling collision detection. So fortunately for us, we do not have to calculate when collisions happen based on like the geometry of the shapes that are colliding. Thank goodness, that would be too much math for like Thursday nights after you've been in school all day. But we are going to be essentially like drawing outlines around different shapes, the sprites that represent game objects, or rather that allow us to see the game objects. So we'll be drawing shapes around them and then using those shapes to determine when a collision occurs so that we can do something based on that. So, imagine we have a player that's a square and an enemy that's a circle. We'll be able to identify when the square overlaps with the circle, and then we'll be able to do something in response to that, such as have the enemy take away a life from the player. That's just an example of something that could happen when an enemy and a player collide. But there's a lot of things that could happen. Animations could trigger You could have to restart the level, whatever. You lose health. And then we'll maybe not today, probably more so in 1 or 2 weeks, we'll maybe be able to customize the colliders as well. For now, we'll just let Unity draw the colliders for us because it's pretty good at that. So when we're talking about physics 2D components, I mentioned that there's different cases where you want game objects to be impacted by certain forces of physics in the game or not. If you have static objects in your game, typically you will put colliders on them if you want them to interact with other things in the game. So for instance, a static platform that doesn't move at all, but that we have to be able to detect a collision with it so that the player can actually stand on it. That would be like a static object that needs to have a collider attached to it. If it was something like just a decoration in the background, like a floating cloud or whatever, that in no way sort of interacts with the player, we don't stand on it or push it around or anything, we wouldn't need to have physics 2D components attached to it, most likely. But if it is a static object that we're actually like interacting with, not to move it, but to stand on it or whatever, then that static object will need a collider 2D. For dynamic objects, though, things that we actually do want to respond to different things happening in the game, like players, like probably enemies, maybe like fancy platforms that respond to being jumped on, maybe things like different like props that you interact with in the game. Those things would need both. So they would need to be attached with a collider as well as a rigid body 2D in order to be dynamic objects in the game. They'll need both. So we won't spend too much time like we have in the past going into too many physics terms, but I think there's a couple that we should highlight just so that when we're using them, which I've already sort of started to use them, it would be good to sort of have like a basic understanding of what these terms mean so that we can throw them around a lot when we're talking about game mechanics. So mentioned a few times is that the physics engine will handle the hard calculations for us, but we have to have at least a basic understanding of the physics concepts that are happening in the game so that when something goes wrong, we can figure out why. So I'm going to start with a discussion about the difference between velocity and speed. I'm not sure if you've heard both of these terms used before. Maybe you've just heard one of them. Maybe you were under the impression that they were the exact same thing. I'm pretty sure before I went into physics 30 when I was in grade 12, I was pretty sure they were the same thing until I learned otherwise. The difference between velocity and speed, if we're looking at the very formal scientific definitions, is that speed measures how fast an object is moving, whereas velocity measures the rate of change of an object's position. So a little fancy talk there. To break it down though, when we're talking about velocity, the direction matters a lot. So imagine that I have a car that's moving at 30 kilometers an hour. When we think about the speed, I don't really care. It doesn't make a difference to me what direction that car is moving in order to understand what the speed of the vehicle is. With the velocity, though, it's important to make a distinction where we understand what direction the vehicle is moving in so that we can calculate where it's actually going to end up. So if I were to talk about the velocity of a vehicle moving, rather than saying 30 kilometers an hour, that's not specific enough to be a velocity, I would say that a car is moving 30 kilometers an hour north or towards, some building, or, it goes in a circle and it ends up at the same spot. So when we are learning about movement in our games, in particular, most likely going to be focused on the player. It's going to be important to understand not just how fast we actually want the player to move, but in what direction we are moving the player. So think about that X and Y axis again. We're going to have to know not only that it's moving, one grid of the, the background of, the scene view at a time, at some increment. We're also going to have to know like what direction it's actually going, right? Is it going at an angle? Is it moving in a negative direction on the x-axis? So going this way, I guess this could be backwards for you depending on how the camera's working. Is it going up? Is it going down? In the view that we're looking at it from using the camera. That's going to be really important. So all of this is to say that we are going to be dealing with something called vector quantities. And in physics, a vector, it's a fancy word for a quantity where both the magnitude, so that's like the size, with the example that would be like the 30 kilometers part of the measurement, is just as important as the direction. So it's always important to consider both when we're dealing with vectors, and we're going to be dealing with vectors quite a bit. Force is also a vector. A force, by like a more formal definition, is an interaction that, unless it's opposed by something, is going to change the motion of an object. So in this GIF, or GIF if you prefer, there are some different forces at play. I'm not sure if any of you have taken physics class in high school, or maybe you've touched on the subject in like a mathematics course. But if you know of any types of forces, in particular types that you can actually see at work in this GIF, where the tobogganer is taking out the person who I think is attempting to do an interview, because I think that's the microphone they're holding. Let me know in the chat if you can mention a specific type of force that is at play here in this GIF. Awesome, yeah. So David mentioned gravitational force. That was the one that I was hoping you would get to first. So I see in that GIF gravitational force, frictional force. You can think of like how much more difficult it would be to slide down that hill if it was the summertime and there wasn't any snow, because of forces, right? The force of a friction that is making it easier for the tobogganer to get down that hill. And then the applied force, of course, of the tobogganer, like ramming into the reporter and having him like flip over and do a somersault. That would be an applied force. So we'll see these types of like forces in our games where objects interact with one another and then physics happens, and as a result different game objects are put into motion in different ways depending on the angle the force is applied and how intense that force is. So I already answered this one, but yes, a force is considered a vector because we're dealing with like a magnitude. So like how intense was that force? Was it a light push? Was it a heavy push? And then like what direction was it applied? In that GIF, we saw the force being applied like at the human's legs. And unfortunately for that human, that meant that, they flipped because their bottom half had that force, hitting into them, which caused the motion of them doing a flip. So we just went through like a lot of content. It's been like 2 hours of content, so pat yourselves on the back. We're gonna do a Kahoot quiz just to kind of get a sense of like how much of that sunk in. We in this course want you all to be successful, but we're not gonna like examine, like have you like write exams and then give you a grade, but we do want to get a sense of like how much the material is sinking in, so we know where to spend our time in future sessions. So we're just going to do a Kahoot quiz just for fun, just to see whether or not you're catching on to some of the concepts. So I'm going to go to Kahoot and start. That's not what I want. I'm pretty sure I'm signed in. Maybe I'm not. Give me 1 second. Okay, I will start the quiz. And bring over this tab. Okay, if you haven't used a Kahoot before, just go to kahoot.it in your browser. You can do it on your phone or you can do it from the machine that you're using to run Unity. And then enter the game pin and join. We'll try to get everyone in. One, two, three, four, five, six. We got 6. We got 9. I think we're almost there. I'll give it one more second, but I think that should be everyone. Oh, there we go. All right. Let's begin. First question of our quiz. Where in the Unity interface might you define parent-child relationships between game objects? Is it the hierarchy panel, the project panel, the game view, or the scene view? Awesome, very well done. So here we're like specifically talking about parent-child relationships between game objects. So hierarchy panel makes sense. Think of like hierarchy of a family. Next question. Where in the Unity interface would you physically place objects in your level? So imagine you're doing some level design, you're like placing in your like platforms and, you know, coins, whatever it is. Yeah, awesome. Seems new. Which of the following components does a game object have by default? We talked about a few of these components. One of them is going to be attached to every new game object you create by default. Awesome. Yep. The majority got that one. That's great. Which of the following properties is not handled by game object's transform component? The scale, the color, the position, the rotation. So that's that component that's attached by default. Super useful when we're placing objects into our scene view. Yeah, awesome. So color is handled by the sprite renderer. That's another one we'll get experience with today, at least a little bit. Question 5, which rigid body 2D setting controls how quickly a rotating object will stop spinning? So each of these were settings on the rigid body 2D component. One of them, though, is responsible for determining how quickly the rotating object will stop spinning. And that is indeed angular drag. Nice work, everyone. Next question. Which of the following terms describes a piece of code that can be attached to a game object? We are going to get some experience writing one of these next week. It's where we write our code, and yes, indeed, it is a script. And question 7, which of the following is not a vector quantity? Force, speed, velocity, acceleration. we didn't really talk about acceleration, but hopefully based on the definition, you might be able to make a guess about whether or not it is a vector quantity. Yeah, that was a harder one. Remember that when we're talking about vectors, both the magnitude of the measurement as well as the direction is important. So speed, by its definition, we care about like how fast something is going, but not necessarily in what direction. It doesn't really matter to us if it's going in a circle, if it's going in a line, if it's going to the right or left. It doesn't matter. But with vector quantities, it does matter. We have to be specific in saying, what direction something is going in order to understand the meaning behind it. If you were to like write a physics exam, maybe you have experienced this before, and you were to, complete an answer by doing some calculation and then saying that, the train was going however many miles an hour, and you were to not include a direction, and you were instructed to report your findings as a vector, you would probably lose marks, I'm guessing. So it's important to say, what direction that thing was traveling as well. And then final question here. Which forces can you see at work here? We have another GIF. Spoiler alert that there may be more than one correct answer, so don't dwell on it too much. Yeah, so no matter what you said, you were right. So congrats, everyone. We saw gravitational, applied, frictional, and normal force. We didn't talk about normal force, but that is just like in that GIF. An example would be like how the water bottle is sitting on top of the basketball, and it doesn't like sink into the basketball. A normal force is causing the bottle to be able to like sit on top of the ball. So we saw all of those at play in the GIF. Let's see who's on the podium. In third place, Alexi, nice work. Second place, Will Granger. And first place, I'm gonna guess it's Austin. Yeah, nice work, everyone. All right. Can everyone hear me? Could someone give? Okay, good. I like heard the sound of my AirPods disconnecting, but I think they reconnected. So hopefully we're all good. Okay. I kind of want to do a check-in just to make sure that everybody has a Unity project open that looks like this. If so, we'll maybe just take like a 1-minute break just to like, refill water, use the washroom or whatever. But we have some more content to get through. So if everyone's cool, I'd like to like jump right into the assignment. So long as nobody needs extra time to get to the point where they have something like this. Oh, I'm only sharing that tab. Sorry, I'm gonna reshare. Something like this is what I meant. Has anybody had a difficult time getting to load a project that's blank that looks like what I have on my screen? Let us know if you have, because we want you to be able to participate in the assignment. And if we need to assist in getting you to this point, then we absolutely will. Okay, awesome. So if you need to, just like take 1 minute, like we'll have the quickest break ever, just to like get up, maybe like do a neck stretch, hydrate yourself or something. and we're going to get started right away. Okay, let's get started. So we are going to do an assignment where you'll have a bit of time to like work through a Google Forms worth of instructions on your own. But I'm actually going to like walk through everything that you're going to be required to do in the assignment if you want to watch. And then that'll make it easier for you to do the assignment afterwards. So I'm going to post in the chat a link to the assignment. It is a Google form, which has instructions inside of it, but it also will allow you, obviously, because it's a Google form, to be able to submit your responses. This is an assignment that we'll hope you'll be able to finish by the end of class. We have about 40 minutes. If you do not finish it in that time, you can submit it without finishing it. It's okay if it doesn't get done. Alternatively, if you want to spend some more time on it outside of class, if you don't get it done, you totally can. That's like up to you. If you want to put in extra time outside of the regular 3-hour sessions, we would just ask that by maybe like Monday or Tuesday, you submit whatever you have, just so that we have a chance to review your responses before class. And we're only going to do that in order to see what concepts we should review the most. So really, this is like just experience for you. We're not going to like grade it or like call you out if you get something wrong. We just want to know what stuff you're struggling with, what stuff you're excelling at, and then we'll base future classes on that. So here's the assignment. We'll start with entering your name, and then part 1 has a set of steps that we're going to have you follow to get used to using the Udemy interface. The first thing that we're going to have you do is create a new hexagon sprite. Does anybody want to take a stab at guessing which of the different panels I could potentially create a new sprite from? I don't think we showed this. Can't remember. Jason showed it while I was explaining sprites. But maybe you can intuit based on, us talking about what each of these panels are for. Yeah, I like where you're going with this. The answer I was hoping for was the project panel, only because that is where I add assets to my games, which I then use to create game objects. So you're like almost a step ahead of me by saying the hierarchy. So I like your thinking. So we are actually going to start in the project panel in the assets folder by creating a new asset. And then we're going to use that asset to create a game object. So
you can create it in either, but if you create it in the hierarchy, then you only have access to like those primitives, just like squares and like circles and things like that. When you get into actual downloading and creating your own assets, you want to do that in the project panel because you can have more than just the basic shapes.
Totally. For our purposes, either one of the hexagons is going to be fine. In the assets portion of the project panel, I'm right clicking and I'm going to set create. And then in the submenu after create, I'm going to go to 2D, then sprites. And then from there, as Elijah asked in the chat, there's an option to create 2 different types of hexagons, a flat top or a pointed top. And you can just choose one of them. It doesn't matter. I'm going to go with the flat top. The physics might be a little bit different in like the simulation that we're going to see. But we're going to get to the same result by whichever one we choose. So again, because it's hard to like remember menu labels, I went create, 2D, sprites, and then I chose one of the hexagons. And over the next few sessions, we're going to get experience with adding a number of these different sprites, because we're going to use these primitives until we get into, importing sprite sheets and, adding our own assets that we find online, or maybe design yourself if you're creative and talented at that sort of thing. So once I create that asset inside of my assets folder, I am going to drag an instance of that sprite into my scene view. And by doing that, it's actually going to create a game object for me, which is pretty nifty. So I'm dragging the hexagon, dropping it into my scene view, placing it into my game. And then as a result of that, on the left-hand side in the hierarchy, which you all guessed would happen, a new game object is added with the name of that sprite. I could rename it, and that'll especially be a good idea as we start to have a lot of game objects. We don't want to have 12 different game objects with the same name called hexagon flat top. I mean, maybe you don't care, but it's probably good to keep things organized. So you could rename it, but I don't know, that's fine for just today. Okay, I'm gonna go back to the assignment. So I created a new hexagon sprite. And then I actually did step 2. I dragged an instance of the hexagon sprite into the scene view. So we did 2 steps. Next up, it asks me to position the hexagon at x equals 0, y equals 2, and z equals 0. Does anybody want to take a guess at how we could go about setting the position of this game object that I just added to my game, which has a hexagon sprite attached to it? Yeah, the inspector. Good job, Danielle. So if I have my hexagon selected in the hierarchy, all of the components related to that game object come up in the inspector. We already have a transform and a sprite renderer attached to this game object. And the transform is the one where we can set the position. So it asks me to set X, Y, and Z. X is going to be 0. Y is going to be 2. And then Z is going to be 0. So let's take a look at what I have now in my scene view once I made that choice. So if we look at like our camera, we can kind of see that based on like I don't know how it's coming through on screen share, but there's like a grid in the background, a bunch of squares, right? And then there's lines that we can sort of think of as the X and Y axis. They're like a little bit darker than the regular grid lines. So right now, it makes sense where my hexagon is if we think about the position we just set it to, because it's right on the Y axis, which means X is equal to 0. It's slightly above the X axis, which means y would be positive. Y is 2, so it's 2 squares up from, where the origin is right here. And then z isn't super important for our purposes. The fact that it's like in front of the camera is all that we really care about, so the camera can actually see it. But we don't so much care about that third dimension, the z axis, right now, because we're making a 2D game. Next up, we're going to rotate the hexagon around the z-axis by 90 degrees. Based on how rotation happens and how it's linked to the different axes, the values that we set here determine how we're rotating around the axis that corresponds with the value that we're setting. This boggled my brain for a long time when I started to learn about like X, Y, Z coordinates. But essentially the Z axis, you can think of it as being like a stick that's shooting through the center of the hexagon right now. So hexagon's here and like there's a line being drawn through it. That's the Z axis. And if we rotate around that axis, it's like we're taking that hexagon and we're spinning it around the stick that's sticking through it. And so by changing the Z axis, the Z value, we're rotating in a way that we can actually like see it from our perspective. So if I set Z to 90, I suddenly went from being a flat top to a pointed top. If you had a pointed top, you may have seen a different result. So that is step number 4. Next up, we can reduce the scale of the hexagon so that it's half its current size. More than likely, in order to change the scale of my hexagon, I'm going to deal with setting the X, Y, and possibly Z values for the scale on the transform. Any idea in order to reduce the size by half, what I would actually want to set the X and Y values to be here? We want it to be half its current size. Yeah, awesome, Adam. So here, even though we're shrinking the game object, the sprite, we are not going to use negative numbers. We're going to use a decimal. So we're going to put it to 0.5. Scale is always going to be positive. And there we go, it's half its size than when we started. We could have doubled it, right? We could have made it 2 and 2 instead of 0.5 and 0.5, but the instructions asked us to make it half its current size. Next, we're gonna repeat the process of creating a sprite. So we have already created a hexagon. Let's create a square now. If you missed this in the first demonstration, I'm happy to be able to show again the process of creating a sprite, dragging an instance into the game, which then creates the game object. So I'm going to right click in assets. There's other ways to do this as well. Like you could do it from the top navigation of like the toolbar that shows up in your operating system. You could create an asset that way as well. And the submenus are the same, but if you are comfortable with doing the right click in the assets folder, you can stick with that method, that's fine. Create is the first menu option that we're looking for. Submenu, we go into 2D. After 2D, we go into sprites. And then after sprites, we choose the sprite that we want to create. And I am creating a square this time. Once the square is created, I can then drag it from my assets folder into the scene view, create an instance of it, and then wow, it created a game object for me. I'm going to pause here just to see if there's any questions or anything you would like me to show again, and then I'll continue on with the steps from part 1 of the assignment. So once the hexagon is appearing inside of the assets folder here, it's just a matter of like selecting and then dragging and dropping it into the scene view. If it is not yet appearing in the assets folder, you need to create it by going to create, 2D, sprites, and then selecting the type of sprite. And I'll just leave this menu open for a second, just in case you want to follow through those sub options. So we have created a new square sprite. We've dragged an instance of the square sprite into the scene view. And then we have, we've done this before, but we haven't done it to the square yet. So it's asking us to transform the square so that its width is 4 times as large as its height. So which value of the scale am I going to be changing in order to increase the width of the square? So by definition, a square has an equal height and width. We're going to turn the square into a rectangle, and we're going to do that by setting one of these values on the scale in the transform. Which one is it? X, Y, or Z? Correct. Trinity with the win. So by increasing the X value, the width changed. So it's now kind of looking like a platform. We're going to position that rectangle, it's not a square anymore, right? So that it's at the center of the game view. So right now, because of where I dragged it in, it's positioned here at -1.4 and 0.44, somewhere around there. We're going to put it right at the origin, which is 0, 0, and 0. So right in the center. We're going to change the color of the rectangle for fun so that you can see how to interact with the sprite renderer. So if I have my rectangle selected in the hierarchy, the sprite renderer will come up with the other components in the inspector, and I'll be able to go to the color field and set some value that's not white, so I can have a more fun color for what is sort of behaving like a platform in this assignment. And then we are going to add a rigid body 2D component to the hexagon. So my hexagon needs to be selected in the hierarchy. And then I'm going to add a component to it. So on the right-hand side, I'm going to go to the Add Component button. And then I could search for the name of the component that I want to add. Remember, we already have a transform, we already have a sprite renderer, but now we're going to add another component. I could search for rigid body 2D, or I could just find it under the section called physics 2D because it's a physics 2D component. And I'm going to add it. Does anybody want to take a guess of what will happen if we press the play button? I don't know if you've done it yet, if you've tried to go from looking at the scene view to opening the game view by playing the game, pressing the play button. But something cool should happen. And yes, indeed, Ernest has guessed it. We should see something fall. The thing that we told it, the thing that we told to be impacted by forces of physics is what we should see fall. So the hexagon. And indeed, we do. So if you missed it, there was a hexagon there before, and now there's not one. If we look over on the right-hand side, this might be like a little small for you to see through the screen share. But the Y value of the hexagon is like plummeting. So even though we can't see the hexagon anymore, the calculation is still happening and gravity is still forcing it to fall into nothing, like nothingness. It just goes on forever. I mean, forever as far as like a computer can compute. But yeah, it's falling. It's continuing to fall even though we can't see it. It's out of the camera's view. Okay, so that was part one. I'm going to stop talking for a bit and just let you go through those steps yourself. If you weren't following along with me, if you got stuck on any part, I can show certain parts again. So just like let us know in the chat or just unmute yourself and ask us to show a particular part again if you missed it. And once you've completed the steps, you can describe what happened in the game view when you press play. Spoiler alert, should be the same thing that you saw happen in my game, right? The hexagon fell. You should be able to answer question 1 and question 2 based on the steps that you took. So feel free to answer this question as well. While still in play mode, ensure the hexagon game object is selected in the hierarchy panel. Do you notice anything happening in the expector panel? And explain. You should be able to answer that question at this point too. So give you some time to do that, and then we'll move on to part 2. Once you have completed the steps outlined in part 1, as well as answered the question in part 1, as well as the question that's right below it, and filled out your name, I guess. Once you've done those first 3 steps of the Google form, could you raise your hand so that I can keep track of who might need a bit more time? Awesome. And again, if there's any particular step you'd like me to show again, I absolutely can. So just let me know in the chat if there's anyone that's given you grief. The Unity interface is like, it's pretty great, but there's like a lot going on. So it can be frustrating, especially when you're learning it for the first time and you like remember what you have to do, but you can't remember where that thing is. So if you've answered the first 3 questions, which includes filling out your name in the Google form, raise your virtual hand, and then once we have the majority there, hopefully everyone, then we'll move on to part 2. We have about 15 minutes left in class, so we should be able to finish up part 2 and 3. And then any remaining time, you'll just get to play around in Unity for a bit. Awesome. I see more hands going up. Yes, Elijah, I'm gonna go into part 2 next, and then I'll walk through part 3. And then if you still have questions, then that'll be the best time to answer them, just to avoid creating confusion until we get there. Thanks for asking. Okay, let's do part 2. I'm going to. I was going to lower everybody's hands, but I guess I can't do that. Interesting. I swear that option used to be on just more drop downs. It's not there anymore. Okay, so
I changed it every time.
Yeah, where did it go? Okay, so part 2. In part 1, we added a rigid body 2D component to our hexagon. Part 2 is asking us to add a collider component to the rectangle. Then we have to do something else to modify the hexagon so that it doesn't fall past the rectangle. So right now, when you press play in your game, if you've followed all of the steps as outlined in the document, you would see the hexagon falling, and then it appears to fall right through the platform, the rectangle, and then plummet, right? We ideally would have the hexagon land on the platform, as if it's a player in a platformer game, right? So we're gonna add a collider to the rectangle, and then we're gonna do something else, and the combination of those 2 things will result in the hexagon landing on top of the platform instead of falling through it. So let's try that out. We're going to add a collider to the rectangle. This process is very similar to what we just did, where we have to select the game object in the hierarchy. I'm selecting the rectangle. It pops up stuff in the inspector. One of the things that pops up in the inspector is an add component button. And then from there, I can either search for the collider 2Ds, or I could find them right under the physics 2D menu. Now in here, there's a number of different types of colliders. There's reasons to use these colliders in different scenarios, especially depending on the type of shape that we're dealing with. So here, because we're dealing with a box collider, we could use, because we're dealing with a rectangle, it might make sense to use a box collider. There's other types of colliders. So we see like polygon colliders, we see circle colliders, capsule colliders, and each of these have their own purposes. The collider isn't always necessarily going to be as complex as the shape. Sometimes you don't need to be, you don't need the collision outline, the thing that we're going to use to detect if a collision took place. We don't need it to be as complex as the sprite per se, because the more complex the shape is, the harder the math is, the slower your game might be. But for today, I'm going to add a box collider to the square. And then I'm actually going to add a collider to the hexagon as well. And there's some options here. I could choose a collider that's less intense when it comes to the math, like a circle collider. That would be perfectly fine. But for demonstration purposes, I'm going to add a polygon collider. So it's going to actually like draw, and this will probably not come through very good on screen share. I can barely see it on my own screen, which is like super good quality, but it's like drawing a green line around the hexagon, around the polygon, which shows, you know, the area that it's going to be using in order to detect if a collision took place. So I just added colliders to both my hexagon and my rectangle. And I hope that by doing that, Unity will be able to detect that the hexagon has actually landed on top of the rectangle. And then because of physics, it's not going to fall through it, it's going to sit on top of it. Awesome. Okay, I'll pause here again while you do those two things and then answer the question to explain how we modified the hexagon, and then answer the question that comes after, which is to explain what type of collider you used for each of the game objects. And then once you've answered, you've responded to those questions 4 and 5, I guess it should be, you can raise your virtual hand. And then the last 10 minutes will be for part 3. If you have any questions about part 2, or you would like me to show the steps again, let me know. I think you should be good, Elijah. We talked about different types of colliders. I don't know if you're here for that, but we're still on part 2. Brief description, Trinity, would be good enough. For part 2. Keep it brief, that's fine. Yeah, so if you used a different type of collider and you found that the end result that we were hoping to achieve was the same, that's fantastic. Ideally, in the question that comes after the section of the Google form that is labeled part 2, you would be able to explain why. Maybe at this point you don't really know, but hopefully we'll get to a point where you'll be able to understand what collider to use in which situation and why. And that'll start to become more clear as we actually like work on our games and like have a player and that player is interacting with things in the game. Right now we're like, you know, dealing with not a lot of interactivity happening in our games. If you have responded to question 5 in the form, what type of collider 2D did you select for each game object and why? then please raise your hand. And if the majority are ready, we'll move on to part 3. Thank you for raising your hands. And if you're not there yet, that's totally cool. Like I said, the Unity UIs can be pretty intimidating the first time you're using it. Just let us know if there's any step that you want us to show again. I'll give it a few more seconds and then I'm going to show part 3. Okay, on to part 3. Perhaps the most complex part, but only a couple of steps. So we are asked to modify settings on the rectangle rigid body 2D component so that when the hexagon and rectangle collide, the rectangle begins to spin but does not fall out of frame. I'm just going back because I don't think we explicitly said to add a rigid body 2D component to the rectangle. Obviously, to be able to modify the settings on the rigid body 2D component of the rectangle, we're going to need to add that component first. So let's do that. So we have a rigid body 2D on our hexagon. We want to add one to our rectangle as well. So it has a collider on it from part 2. I want to add a rigid body 2D component to it as well. So at this point, both of my game objects that we are seeing as sprites in our game, both the hexagon and the rectangle, both of them should have colliders. You may have different types of colliders based on what you chose to add. Box, circle, whatever. And they should also both have rigid body 2D components. Make sure the colliders as well as the rigid bodies are both the 2D versions. They should say 2D at the end of them. And both of those games objects should have them. So as I switch between hexagon and square, we see one of each of those types of components on either one of them. Now at this point, something kind of silly is going to happen when I press play. Anyone want to take a guess? You might have done this already. Now that I've added a rigid body 2D component to my rectangle as well as my square. Yeah, Danielle's right. They're both going to fall. So yeah, that's, it's not what I want the end result to be, but we're getting there. So let's go back to the description here. So it says modify settings on the rectangle's rigid body 2D component so that when the hexagon and rectangle collide, the rectangle begins to spin but does not fall out of frame. So first things first, let's focus on the part that says it doesn't fall out of frame. So we're going to have to ensure that gravity is not causing it to fall, but that other forces can cause it to move. So we keep the rigid body 2D component on it. It's okay that it's being impacted by the physics engine, but we have to change it so that the gravity isn't impacting it. So with the rectangle selected in the hierarchy, I can set the gravity scale to 0. So again, select the rectangle in the hierarchy panel, go over to the inspector, find the rigid body component, and then set the gravity scale setting to 0. And that basically says, in our little simulation here, that the hexagon falling onto the rectangle is going to put it into motion, but gravity itself is not going to cause it to fall. So we should see something. There we go. So it's still falling out of frame, but it's only doing so because the hexagon's weight on top of it is causing it to fall out of frame. Now what the assignment asks us is to make sure that it doesn't fall out of frame at all, regardless of whether or not the hexagon is, sitting on top of it, weighing it down. So there's 2 other settings that we're going to change, and then that'll be it for today's class. Other than to finish filling out this form, if you'd like to sort of explain what it is that you've learned by doing this exercise. So I am going to set the linear drag to be very high. So basically nothing is stopping, nothing is going to stop the rectangle from spinning, but everything is going to stop it from moving. So moving position, I should say. So we're going to see with a high linear drag and a low angular drag, something like 0. High linear drag, low angular drag, we should see that once this hexagon falls on this platform, it's going to sort of push it down a bit. It's going to kind of roll off of it, and that's going to cause the rectangle to start spinning, but it's not going to push it down out of the view. So much linear drag means that once that force is no longer being applied, boom, it's just starting to spin. There's nothing to stop it from rotating, but there's everything to stop it from moving out of the frame. So assuming that all kind of sunk in, and it's okay if it didn't, like we've filled your heads with a lot of information over the last 3 hours. But assuming that did all make sense, then we'll have you answer the last 3 questions. So explain the settings that we changed, why, what happened, describe the forces at work in the project at this point. And then, if you were done already, if you kind of moved ahead and did part 3 on your own, you could tell us what other things you experimented with while you're playing around in Unity. It is 8:31 now, so I know you've probably had long days of school and followed by 3 hours of boot camp. So if you need to jump off the call, that's totally fine. I just have one piece of homework for you, which is to confirm that Visual Studio is installed on your machines before next week. This was part of the setup for class today. It should have been something that came with Unity. We just want to double check because we might not have time to install it during the start of class next week. Visual Studio looks like it's got an icon like this. So you should have, by installing through the Unity Hub, the version of Unity, based on the default settings and what we asked you to confirm was selected on, you should have an application with this icon called Visual Studio. And we're going to be using that to write code next week. Okay, so if you want to stick around and ask a question or 2 or get help with just completing the Google form, then please do. But otherwise, you're free to go. And I look forward to seeing you all next week.
Yeah, well, next week.
Thank you.
See you.
Bye.
Yeah.
Thanks, everyone. I'll have the video link sent to everybody maybe tonight for sure by tomorrow. Okay. Thanks again.
Awesome. For Maxim, I just selected the camera in the hierarchy in case you want to confirm that the position of your camera is the same. And then So Visual Studio will be installed as like a separate application. The Unity Hub handled installing it, but it'll appear like where other applications appear on your machine. So like for me on a Mac, it's in like the applications folder. For Windows, it's going to be like in the start menu. Is that where it is in Windows? Is there a start menu in Windows now?
Yeah. If you go to the Windows key and just type in Visual Studio, it should come up. If you search your programs. So it's not really part of the Unity Hub necessarily, it's just a program that also got installed.
Yeah.
We'll open it through Unity, but it should be installed just as a program.
Really?
So.
Yeah, if you don't have it, it would be a good idea to install it. I think it's probably easier to do it like through the Visual Studio website, I want to say, rather than like adding a module, but I don't really remember. Let's see.
Yeah, so what you need is it's called Visual Studio Community, right? That's the version of Visual Studio that you want, I think. And that's the one that Unity installs for you.
It looks like there might be a way to do it through the hub. But if you have any issues with this, then just going to Visual Studio's website is probably going to be a whole easier. But yeah, you can add a module by clicking the cog on the like install. And mine's already installed, but Visual Studio should be an option. That ideally was checked off when you started the install, but it might have accidentally got unchecked, or for whatever reason it wasn't added to the default tools to install. Oh,
Yeah,
good. You got the community.
That should work.
Okay,
Yeah.
awesome. Sounds great. All right. We'll see everybody next week. Have a good night.
Bye.
Bye.